Thank you, Wes. And it's only day one, and we're coming out with jokes like that. Very, very poor. Okay, well, it's great to be with you, whether you're here in person or online. And I want to take you through this. He's stolen my thunder, so this is just my history. So I literally joined Appear 6 months ago this week. So this is my new home, and I'd just like to give a little plug for my podcast. As many of you will know, I have an appetite for tea. So you can search for Time for Tea with Andy Rayner on any podcast subscriber, and you can get that. We're going to be doing a new podcast, releasing a new one at the end of this week from the show. Getting into the content of this presentation, what content creators want, and I use this slide quite a lot to summarize the fundamental principles that we are trying to address as technologists. Basically, content producers want a lower cost, and I'll go on to explain what I mean by viability a bit later on. They want to be able to have a higher production value, to be able to make the production look cooler in whatever way that was, and they want more flexibility. So those are the key requirements that content creators have in the way they approach it. Another slide I use a lot is a slide I helped the DPP evolve 4 years ago. During COVID, we worked on this, and this is really just a documentation of the way live production is now being done. So basically, live production was done originally like at the top, the traditional on-location model where your acquisition, your data storage and processing, and your control is all co-located, typically in a television studio or in an OB truck. That was the way things were. Now what we're doing is we're doing more and more distributed production. So your acquisition may be a very different location to where the equipment that's doing the processing is, which in turn may be a very different location to where the controller's based. And that was very accelerated, some of this by COVID, of course, when people could not be physically present in some places. And this really it's not revolutionary now, because this is business as usual. There are lots of benefits of this in terms of pooling of equipment, making more efficient use of people because you don't have to move the people. And obviously that has environmental and sustainability benefits as well as cost savings for content creators. Another key observation which impacts what I'm talking about is we are moving as a broadcast media industry from the bespoke to the generic. So we have in the past had many things that are entirely bespoke. We had BNC connectors and XLR connectors, to be fair. We still have quite a few of them, but more and more we're moving to Ethernet connectors for the way we interface both video and audio. That means we're not worried about the physical layer interface anymore, and we gain all the benefits. There are some challenges that go alongside that in terms of hygiene, security, etc. Very similarly, we're actually virtualizing a lot of the processing that we do. What was the preserve of individual nice glowing racks of equipment that had one specific function now are, largely speaking, software things that are spun up on servers. Then we have, further to that, dematerialization. So those servers that you're reading your stuff up on may not even be in your premises. They may be somewhere else in the world. Courtesy of Felix Poulon, that term. One thing that's very important and pertinent to this talk is moving from the bespoke to the generic in terms of connectivity. So until a few years ago, all broadcast connectivity for live production was on private lease line connectivity. More and more of these live programming is now moving to internet-based, public internet-based connectivity, which is quite revolutionary. And what I'm going to be doing most of this talk is explaining why that is now possible, what the challenges are, and how we're overcoming it as an industry. One more bespoke to generic slide, which is on the RF side. So we've done lots of very expensive RF engineering in the past in broadcast, mainly satellite-based and very bespoke custom camera tools to actually allow us to do RF short distance and long distance connectivity. Now with 5G offering big bandwidths and lots of other capabilities and low Earth orbit satellites, etc., as well as geosatellites, we've actually got lots of capability we can use natively that's generic stuff that we're actually running over. So into the meat of what we're talking about here, the pros and cons of using public internet connectivity for live production. Okay, so the biggest reason why you would do this, which overrides everything else, top left, is cost. The cost saving from using public internet connectivity rather than private lease lines can be at least tenfold, many times hundredfold, or even more. So it's an unbelievable cost saving if we can actually make use of that. So that's something that's on the down, the cost. What we've also got is a few negative downsides from doing this as well. First of all, reliability. So the reliability of the connection, first of all, one of the fundamental things about most public internet connectivity is it's contended. So you don't have necessarily all the time all the bandwidth that you may think you've got. The actual bandwidth level itself is actually typically on public internet connectivity quite a lot lower than you can get on private lease lines. Private lease lines, you can basically have as much bandwidth as you're willing to pay for. Whereas in public lease line, you can get tens of megabits per second very, very safely and easily. But if you want hundreds or thousands, or gigabits, then it's actually potentially more of a challenge. Thirdly, third negative is there are potential security challenges. One of the good things and one of the reasons we've been probably lax as an IP media industry for a while, or a media industry in general, is on some elements of security for many decades is because private lease lines were inherently secure. If we're going over public internet connectivity, then security is an inherent issue. There are some more pluses though. So not only does the cost come down, we've actually got much better reach because pretty well everywhere has got some degree of public internet connectivity that we can make use of. So intrinsically, you can plug and play in many places where it may take you 3 months to get a leased line installed for an extortionate cost. And that provides much more flexibility in the way you do things. However, there are some more rising negatives in there as well. Latency is one. So typically, you're going to have a much more latent connectivity if you're going to have a public connectivity, both from the intrinsic data transfer mechanisms that are being used, but also, and we'll come to this in a minute, from the protection mechanisms you need to wrap around it to make it viable, given things like the reliability we talked about earlier. And jitter is in a similar manner to that. So, what are the enablers that we have that actually make public internet for live production viable? Well, why is this possible now in 2024 when it probably wasn't possible in 2004 when we all had some kind of internet connectivity? First of all, public internet connectivity is a much higher quality than it used to be. So internet service providers, the whole internet backbone is bigger, it's better, it's more capable of doing what we need. So that's a fundamental thing that's continually on the rise. Higher bandwidth connectivity is becoming available. So when I think I got my first DSL at home, I was very excited to get 2 or 3 megabits per second. Now it's the preserve, even on VDSL, to get 100 megabits per second. And if you're getting fibre to the home, fibre to the premises, wherever you are, for public internet connectivity, a gigabit is not unusual and very achievable. More reliability. So again, the whole network provision is actually becoming better and better, and there's more reach. Security tools are available, I'll come to that in a minute, which actually give you the security you need when running over public internet connectivity. We have integrity tools, I'll unpack that in a minute as well, which help us to actually give the integrity that we need as well. The performance is better in terms of jitter, and in general, there's better contention management now in the way that you actually are provided with the connectivity for public internet. Now, I mentioned in one of the terms earlier the word viability. And I think one of the things that this type of connectivity and using it for production does is it enables live production of events that literally were unviable from a commercial perspective prior to this kind of connectivity being available. If the connectivity costs a tenth or a hundredth of what it would do to provide that connectivity, and you can pretty well have it instantly, then actually suddenly producing live coverage of events that would have been very, very costly previously is viable. So that's incredibly important. So I talked about the need to protect the integrity of public internet connectivity, and there are basically three main tools that we have in the toolkit. This is nothing specifically to do with public internet connectivity that we are using in general. The first one is something that I was involved in realizing before it was even standardized as 2022-7. I think I did our first implementation probably getting on for 14 years ago. And this is RTP merge. So basically, it's a spatial diversity technique. You actually route the same traffic over two physically diverse routes simultaneously in parallel. So there's a double bandwidth hit in doing that. You actually merge them on a packet by packet basis at the far end. That is a very, very good way of protecting. It gives you no additional latency for doing it, because literally all you're doing is aligning the latencies of the paths as you do the merge. And it's a 1-for-1, but the penalty is 100. You need diverse routes, and you need to be able to get diverse routes, which certainly with public internet connectivity is unlikely. And also you've got to pay for it. It's double bandwidth. FEC is something that's been around. Obviously, it's around in any RF modulation spectrum. FEC is also used in Ethernet. You know, as again, all of these are lower level things to actually make things happen. FEC has been defined for both compressed and uncompressed video transport, and many service providers and broadcasters are using that as part of the toolkit, and that can actually have some useful support in public internet connectivity. But the biggest one that's actually really making public internet connectivity work in a deterministic manner from the user perspective is ARQ technology. This is basically the concept where at the far end you're monitoring for lost packets and you're asking them to be resent. So the packets are cached at the transmit end and they are resent on demand if they've been lost. That's actually it's kind of analogous. It's a kind of an inverted polarity TCP mechanism, but actually doesn't have all of the hassles that TCP has in terms of the windowing and the bandwidth limitations. So this ARQ technology, there are some tools in the two biggest tools, RIST and SRT. I'll come on to them in a minute. The biggest penalty of using this is latency, because basically there's inherently at least a 1 round trip latency that you're going to incur in doing this to make it work. So basically what we're saying is you've got to say at the receive end, I've lost that packet, please resend it. So you've got that whole round trip time to actually do. And some of it is recursive, so it's more than once going round that loop. So it can be several iterations of the round trip of the transit of the data. I talked about SRT and RIST. These are the two protocols that are in most use. SRT is a non-open standard, but it's been made available by the company that developed it to be used as a module in various pieces of equipment, and it has become the de facto standard, even though unfortunately it gives you non-compliant RTP level in the transmission that you send out. RIST is an open standard developed by the Video Services Forum, and this actually has quite a few advantages, but hasn't had the market traction that SRT has had. Both of these tools have inbuilt security mechanisms to actually give the security that we need to make this work. So let's look at the ARQ process and what that means. So as I said, it's a round trip process. So you've got n times round trips to make it behave. We've actually developed in Appear some very high speed, high bandwidth accelerated SRT tools as part of our toolkit in our product. And I was talking to some of our team that actually are involved in giving this to the customers, and they're saying typically the SRT buffering can vary anything between 100 milliseconds at the low end up to, and you're going to 8 seconds as some of the usage for things that are very non-latency critical and with very, very harsh environments. So it's incredibly application dependent. Now, the only fundamental we can't change is the law of physics. So basically, it costs you about 200 milliseconds to go around the circumference of the Earth in terms of the speed of light in fibre. So you've got to factor in your route length and then your multiples of that when you're actually thinking about the latency that's incurred as part of that. So latency limitations in reality. So we're talking in a production about typically going from wherever the acquisition site is into maybe cloud or data center compute, or maybe to a broadcaster's premises, some combination of those connectivities. And the reality is that depending on what part of the production chain you're in, that latency may be more or less critical. So if you're talking about some of the main ISO feeds from cameras at a sports event, then you want them to be fairly timely coming back to the production center if you're doing a remote production, or into the cloud interface. It's worth saying, as a friend of mine, Andy Beale, pointed out in a session I was doing with him earlier today in the conference elsewhere at NAB, that actually not all cameras at a production like that need to be treated with the same latency requirements. Probably in a multi-camera sports production, you've maybe got 2, 3, 4, or 5 cameras that actually need to arrive in synchronism and with relatively low latency. You've got a whole plethora of other cameras, like behind the goal cameras, beauty shots, which actually, if they're 500 milliseconds out of time, it really doesn't matter, because they're actually being used either for replay servers or they're actually being used as cutaways. So the actual time alignment and latency of that is really, really not critical. So some of those latency requirements are different. There are some other challenges, like with return latency, that's actually very critical for people, for talent and presenters that are working on screen. One anecdote, for those of you that follow me on LinkedIn, I did actually post some data for my flight over on Friday to NAB, because I'm a bit of a geek, it has to be said, and I do quite often look at the performance of my data connectivity wherever I am, and I'm especially interested when I'm in aeroplanes. One of the things that amazed me, and this is actually quite a good consistent performance, was the consistency of the round trip time of my ping tests to the Google server. We're actually within about 20 or 30 milliseconds consistently. If you can't see that on the screen, around the 700 odd milliseconds round trip, which, consider you're bouncing off probably a geostationary satellite and back again and going around that loop, is pretty impressive. But one of the things I wanted to point out here, that consistency of delay is actually very, very important. And from a broadcaster perspective, the absolute delay is not as critical in many applications as the consistency of the delay, which is very, very important. So what's needed to make this happen? So to make this connectivity over public internet happen. So first of all, we need that good enough internet connectivity. There needs to be a baseline of good enough. We can put the tricks around it, but it needs to be good enough to start with. We need sufficient time budget to cope with both the latency of the connection inherently provided and the latency of the protection mechanisms which we're wrapping it in. We need sufficient protection mechanisms that we can run on the system, and we need to have transport solutions that actually have those protocols at the speed we want to actually run. So all of those things are very important. I did allude to the fact that in the security perspective, we're interested in the data plane, and we're also interested in protecting the control plane. And I'll come on to that in a second. Many, many application spaces we're seeing this being used for. A lot of contribution in and out of cloud is very important. Also replacement of a lot of satellite connectivity, especially for feeding to affiliates, etc. And literally ISOs for doing remote production where latency is not a problem, and also where we do have cost viability for you doing other things. A quick plug for a standard which the VSF came out with last year, which actually addresses some of these connectivity and security issues, both in the control and data plane, which is TR09. I encourage you to check it out. A couple of observations on public cloud infrastructure. The connectivity in and out of that is actually something that a lot of these tools use, and public internet connectivity is used a lot to get in and out of public cloud infrastructure. And if it's treated with the same wrappers and same security protocols, then and the same diversity and protection protocols, then this can actually be incredibly valid. And just an anecdote from me, a personal anecdote outside of my day job. At the beginning of COVID, on every Sunday, our church service, we started doing live broadcasts with remote production toolkits as part of that. And actually, 4 years on, with very, very low cost public internet connectivity, we've had 0 failures in 4 years and over 200 events that we've done for that. And so it just goes to prove that there is a risk margin, a risk management, because actually, most of the time, this whole thing works really, really well. And from our vendor experience, it appears the high density SRT capability that we have within the product has really enabled many, many customers to actually use this in volume for live productions throughout the world, which is great. So it only remains for me to say thank you for watching and thank you for being part of this session. And I would like to invite you to our booth where we actually do pretty decent cups of tea, even here in the USA. If you want to get in touch with me, my details are on there. I'd love to follow up with you. We're actually located only about 1 minute's walk from this IP showcase here in the West Hall. So thank you for your attention, and any questions?